Hello everyone, in today's video I will demonstrate that if you had the opportunity to meet Albert Einstein, you could complicate and confuse him with one of the most advanced and challenging branches of physics, quantum mechanics. So let's begin explaining quantum mechanics to Albert Einstein. Professor Einstein, quantum mechanics constitutes a paradigm shift that necessitates a non-abelian reinterpretation of classical determinism via the integration of non-local hidden variables in a high-dimensional, non-relativistic quantum field theoretic framework. The foundational postulate, encapsulated in the spectral decomposition of the density operator, entails a probabilistic manifold where the superposition principle allows for an infinite set of orthogonal quantum states, each represented by a vector in the complex Hilbert space T, whose interactions yield state vector entanglement as an emergent phenomenon at the interface of the superposition principle and decoherent evolution within the system environment paradigm. The notion of wave function collapse, mathematically represented as a non-unitary process governed by the Luder's rule, introduces an irremovable epistemic incoherence, where the so-called measurement problem diverges into disparate schools of thought. Ranging from the many worlds interpretation, postulating an infinite branching of the universal wave function into orthogonal quantum histories, to the transactional interpretation, which invokes retrocausality and time-symmetric boundary conditions to explain quantum phenomena through the exchange of advanced and retarded waves in the Feynman propagator formalism. Interspersed within this ontological quagmire lies the delicate interplay of quantum entanglement and the non-locality inherent in quantum correlations, which renders the classical space-time continuum inadequate to explain instantaneous correlations, thus violating the Einstein-Podolsky-Rosen criterion of local realism. Bell's theorem, via the violation of Bell inequalities, fortuitously presupposes the necessity of non-local hidden variables which are unable to reconcile the core tenets of quantum field theory with any form of Einsteinian locality, invoking profound epistemological perturbations to our classical conception of separability and individuality. Furthermore, the topological quantum field theory, TQFT, encoded within the modular invariance of string theory, alludes to a quantum holographic duality, specifically the AD-S-CFT correspondence, where quantum gravitational effects in anti-de Sitter, AD-S, spaces are emergent phenomena arising from lower-dimensional conformal field theories, CFT, suggesting a deeper underlying mathematical symbiosis that obfuscates the very nature of quantum space-time itself. Lastly, leveraging the path integral formulation of quantum mechanics, the sum over histories incurs an infinite, non-analytic transformation of the classical action integral into complex-valued nonlinear regimes of quantum fluctuations, implicating not only an immanent uncertainty principle, but an absolute indeterminacy of global causality, thereby reconciling our understanding of quantum fluctuations with the transcendental nature of Planck-scale events, where quantum gravity is presumed to emerge from a non-perturbative quantum chromodynamics vacuum state. In summation, quantum mechanics effectively obliterates the conceptual boundaries of locality, determinism, and separability, necessitating a paradigmatic recalibration of both the conceptual and mathematical frameworks in which physical reality is construed, as every quantum system inherently incorporates non-trivial entanglements, precluding any deterministic worldview from surviving the quantum regime. Quantum mechanics disrupts classical determinism with non-local variables in high-dimensional field theory. Spectral decomposition of the density operator reveals infinite entangled states. Wave function collapse via Luder's rule amplifies the measurement problem. Bell's theorem defies local realism, exposing non-local correlations. AD-S-CFT duality unites quantum gravity and field theory. Path integrals suggest quantum indeterminacy, transforming classical action. Quantum mechanics redefines locality and determinism, reshaping reality.